What if I told you that Earth, this planet we walk on, sleep on, and occasionally complain about because of traffic and Wi-Fi, might have already hosted an intelligent civilization long before humans, or even dinosaurs, ever existed? That cities, machines, or something resembling society might have once sprawled across landscapes that today are deserts, oceans, or mountain ranges. It's the kind of question that sounds absurd, like the setup to a cosmic joke, but it's exactly the kind of thing scientists consider when exploring the Silurian Hypothesis, a thought experiment asking, could intelligent life have existed on Earth millions of years before us? And if so, how would we even detect it? And here's the kicker. The Earth is a really good eraser. It's so thorough that finding evidence would be like trying to locate a dropped earring after a Category 5 hurricane and a minor earthquake combined. To understand why this is even remotely plausible, we need to wrap our heads around time on a scale that makes humans look like toddlers in a sandbox. Dinosaurs first appeared roughly 230 million years ago. Modern humans? About 300,000 years ago. That's less than a blink compared to the sweeping arc of geologic history. If a civilization existed before dinosaurs, we're talking millions of years. A duration so vast that even the most indestructible human creations might vanish entirely, reduced to chemical traces indistinguishable from ordinary rock. In other words, your smartphone, your car, or even the Great Wall of China might not survive 100 million years. Probably a relief if you were worried about leaving your internet history for future archaeologists to judge. Earth itself is partly to blame. The planet is a restless, recycling machine. Tectonic plates drift, mountains rise and erode, oceans appear and vanish. Volcanoes erupt, ice ages scrape continents clean, and sediments bury whatever survives. In some sense, Earth is the ultimate minimalist. No clutter, no lingering traces of failed civilizations, just layers of rock and fossilized hints carefully cataloged for anyone patient or obsessed enough to dig deep. And humor, of course, lies in imagining that our future archaeologists or alien visitors might scratch their heads at something that looks suspiciously like a stone quarry and wonder, were these primitive humans or some really clumsy civilization? When scientists consider the Silurian Hypothesis seriously, they start with what would survive. Structures, tools, and machines are all fragile on geologic timescales. Stone might persist, but erosion wears it down. Metal corrodes. Plastics eventually break down into molecular traces. Only very resilient materials like certain ceramics or radiogenic isotopes altered by industrial activity might last hundreds of millions of years. In other words, if there was a civilization before us, it probably didn't leave much behind, and what remains might be so subtle that we'd mistake it for a weird rock formation or an anomaly in sediment chemistry. And honestly, the idea that a species could engineer all of that, only for future humans to find nothing, is kind of hilarious. It's like winning a galactic gold medal and then leaving it in a compost heap. We can also look at the fossil record to see why this hypothetical civilization could remain hidden. Fossils are rare, fragile snapshots of life, biased toward creatures with bones or shells that fossilize easily. Soft tissues, clothing, or paper, anything resembling human artifacts, don't fossilize. Layers of volcanic ash, shifting rivers, and continental drift erase evidence of almost everything. So even if there were cities, roads, or advanced machinery, the Earth would treat them like sandcastles at high tide. The humor sneaks in naturally. Millions of years later, the only clue might be a strangely shaped pebble or an odd isotopic ratio in rock, while the civilization itself has vanished without a trace, like a cosmic April Fool's joke. The Silurian Hypothesis doesn't claim that there was a civilization before humans. Instead, it asks a very simple, humbling question. How would we know if there had been one? Scientists imagine looking for chemical signatures in sediments, unusual mineral deposits, or traces of industrial pollution in the geologic record. Even small deviations in carbon isotopes could hint that something unnatural occurred. It's the scientific equivalent of noticing that your living room carpet has an inexplicable stain and asking, did someone spill soda? Or is there a hidden raccoon civilization we've been ignoring for millions of years? Time scales in the hypothesis are key. Earth is about 4.5 billion years old, and complex multicellular life has only existed for roughly 600 million years. Dinosaurs arrived 230 million years ago, and humans are a recent blip. That leaves hundreds of millions of years where a civilization could theoretically exist without leaving obvious traces. And here's the funny, terrifying part. We assume the Earth is static and predictable, but it's not. Massive volcanic eruptions, asteroid impacts, and ice ages could wipe civilizations off the face of the planet entirely, leaving only faint chemical whispers in rocks or ocean sediments. The universe has a long memory, but it also has a very selective filing system. We can look at analogies from human history to understand this. Consider ancient civilizations like the Indus Valley or the Maya. Even after just a few thousand years, cities vanish, monuments erode, and forests reclaim roads. Now imagine that process stretched across millions of years, amplified by continental drift, meteor impacts, and oceanic subduction zones. Humor comes naturally. Our digital empire, with TikTok, skyscrapers, and online memes, could vanish almost entirely given enough time. Perhaps future species will stumble across an anomalous layer of plastic and mutter, early humans were ambitious, and then move on. Scientists also explore the idea that certain industrial byproducts might persist in ways we can detect. Heavy metals, synthetic isotopes, or traces of nuclear reactions could remain in sediments for hundreds of millions of years. If a civilization had harnessed energy on a planetary scale, burned coal, or processed metals, it might leave behind subtle chemical fingerprints. Detecting these would be like finding a cosmic breadcrumb in a geological maze, small, fleeting, and almost certainly unintentional. The humor? Humanity spends billions of dollars on science to detect these traces, while the planet quietly erases evidence like a stern librarian shushing over-enthusiastic students. Imagine a world where simply looking at something changes it. Not metaphorically, not philosophically, but literally. You can measure a particle a certain way, and the universe responds differently just because you peaked. That's quantum mechanics in action, and for scientists, it's equal parts exhilarating and terrifying. Think of it as the universe giving humanity a cosmic prank that never stops. A punchline we may never fully understand, but we keep laughing nervously anyway. At the core of this strange reality is something called superposition. In the quantum world, a particle can exist in multiple states at once. It's not flipping a coin in midair, it's being all possible outcomes at the same time until we observe it. When we check, the particle suddenly decides where it wants to be. Humans, with our love for certainty, are understandably unnerved. And yet, there's humor here. We've built enormous machines and complex equations just to watch tiny particles play hide-and-seek with reality. One famous thought experiment captures this absurdity perfectly: Schrödinger's cat. Imagine a cat in a box with a mechanism triggered by a decaying atom. Until you open the box, the cat is theoretically both alive and dead. It's not a joke, but it reads like one, a tiny feline forced to exist in two states while humans argue over physics. Scientists use it to explain how quantum rules clash with everyday logic, but anyone with a pet might also use it as a cautionary tale for not leaving cats in boxes. Quantum phenomena like this aren't confined to thought experiments. Experiments show that particles behave differently depending on whether we observe them. The double-slit experiment is a classic example. When electrons pass through two slits, they create an interference pattern like waves overlapping. But measure which slit they go through, and the pattern vanishes. They behave like individual particles. Observation literally changes behavior. If you've ever argued with a toddler who refuses to eat vegetables until you look away, you have some idea of the cosmic scale of this principle, just with fewer tears and slightly more math. Then there's quantum entanglement, a phenomenon Einstein famously called spooky action at a distance. Two particles, created together, remain linked regardless of distance. Measure one, and the other instantly reflects the outcome, even if it's across the galaxy. It's like having a pair of dice where, no matter how far apart they are, if one comes up 6, the other always mirrors it. Spooky, baffling, and slightly hilarious if you think about the universe playing this game while humans fret about Wi-Fi outages. And it doesn't stop there. The measurement problem raises the terrifying question: why does observation collapse all possibilities into one reality? Is reality fundamentally probabilistic? Does consciousness play a role in shaping outcomes? Some interpretations propose parallel universes branching off with every quantum event. Others suggest hidden variables we can't yet detect. All of them work mathematically, yet each suggests something profoundly unsettling about the world. It's like trying to follow a recipe while the ingredients keep changing depending on whether you're looking. Despite the weirdness, quantum mechanics powers much of modern technology. Semiconductors, lasers, MRIs, and GPS all rely on quantum principles. Superposition enables quantum computing. Entanglement may revolutionize cryptography, and the rules that terrify scientists are the same rules that let us stream videos without buffering. Well, most of the time. There's humor in that contrast. The universe behaves like a trickster at microscopic scales, yet those same rules allow us to binge-watch cat videos in high definition. Experiments like the delayed choice quantum eraser push our understanding further. They suggest that actions taken now can retroactively influence past events at the quantum level. Cause and effect, once considered sacred, becomes conditional, context-dependent, and utterly counterintuitive. The universe is not malevolent, it's just extremely difficult to predict. And the humor is inescapable. Humans planning life choices while the universe occasionally rewrites history for a particle somewhere. Interpretations of quantum mechanics multiply the strangeness. The Copenhagen interpretation emphasizes measurement and collapse. Many worlds posits infinite branching universes. Pilot wave theories suggest hidden deterministic variables. All give the same predictions, but tell wildly different stories about reality itself. Scientists argue passionately over these ideas, which is both impressive and slightly absurd. A species capable of landing rovers on Mars is still debating the nature of existence at scales we can barely detect. Even Schrödinger's cat becomes stranger under scrutiny. Imagine millions of particles, each existing in superposition, entangled across distances, and influenced by observation. It's as if reality itself is running a surreal sitcom, with humans as both audience and unwitting participants. The jokes are subtle, the plot unpredictable, and every observation changes the punchline. Terrifying? Absolutely. Hilarious? If you survive thinking about it, yes. Consciousness enters the paradox as well. Some interpretations imply that the act of observing might require a conscious observer, raising questions about mind and reality. Do particles exist in definite states only when noticed? Are we, in some sense, collaborating with the universe to shape reality? Humor creeps in again. Humans, a tiny species, attempting to negotiate with reality itself. And yes, sometimes the universe seems to snicker back. Entanglement and information further twist the story. Teleportation experiments replicate quantum states over distances, not moving matter, but transferring information. The particles behave as if distance is irrelevant, reinforcing the spooky nature of the universe. Scientists continue to test, measure, and theorize, often shaking their heads in disbelief, occasionally laughing at the absurdity. Imagine explaining this to someone at a dinner party. Oh yes, particles communicate instantly across space, but your leftovers are safe. What makes this paradox? Extinction events and climate change would have tested their resilience. Ice ages, megavolcanoes, and asteroid impacts would challenge any species attempting to survive millions of years. They might have developed adaptive technologies, migrated across continents, or even retreated underground, leaving fossil evidence in caves or subterranean layers. The humor? Despite all this effort, Earth could still erase their legacy in ways so complete that we might never know they existed. Our curiosity destined to gaze at ordinary rocks and wonder if they were the remnants of something extraordinary. Even the ocean could hold clues. The seafloor preserves layers of sediments that sometimes contain microscopic traces of life or chemical anomalies. If a civilization existed near coastlines, rivers, or shallow seas, their activity might leave subtle fingerprints. Minerals concentrated by early metallurgy, unusual isotopes, or even traces of biochemistry altered by industrial processes. Humor enters again. The ocean swallows civilizations as casually as a dishwasher swallows plates, leaving future scientists marveling at faint patterns and wondering, what the heck happened here? Meteor impacts offer another twist. Large collisions can reset the planet's surface, erasing cities, forests, and even entire ecosystems. If a pre-dinosaur civilization existed during such a time, much of their legacy could have been vaporized in a single cosmic event. Humor sneaks in. Imagine your species mastering agriculture, architecture, and art, only to have a space rock make an uninvited cameo and declare, "Sorry, nothing personal." Then there's the question of intelligence and culture. What would a civilization millions of years ago even look like? Would they have been upright, humanoid-like creatures? Or something utterly alien, evolved in ways we cannot imagine, leaving traces we might mistake for natural formations? Could they have built machines, experimented with chemistry, or explored the skies? Humor arises naturally. Maybe they had board games, pets, or something akin to social media, only for it all to vanish without a trace, leaving us to speculate endlessly. The thought experiment also forces reflection on human fragility and temporality. Our entire civilization is only a few thousand years old, a fraction of the time that life has existed on Earth. The Silurian Hypothesis suggests that civilizations could rise and vanish entirely without leaving obvious evidence. In other words, we might be the new kids on the block, oblivious to the cosmic history that preceded us. Humor sneaks in. Humans worry about trivial things like Wi-Fi speed, while the Earth has seen entire civilizations rise and vanish like morning dew. And yet, in the midst of all this, there's hope for discovery. Scientists are developing sophisticated techniques to detect ancient industrial activity or unusual geochemical patterns in sediments. Using isotopic analysis, sediment cores, and comparisons with natural processes, it might one day be possible to spot faint signals from a long-lost civilization. Humor is subtle but present. We're like archaeologists examining a pile of dust and saying, maybe this used to be a skyscraper? With the universe politely chuckling at our determination. Even climate and geology provide clues. Changes in atmospheric composition, sudden shifts in carbon ratios, or anomalies in oxygen levels could hint at large-scale biological or industrial activity. Perhaps a civilization once burned coal or processed metals on a massive scale, leaving detectable chemical signatures for millions of years. Humor enters naturally. The Earth is a patient archivist, recording everything while humans spend millennia obsessing over Instagram hashtags. Speculation can even extend to technology that could survive geologic time. Advanced ceramics, alloys resistant to corrosion, or subterranean structures might leave traces detectable in the rock record. Even if cities eroded, roads vanished, and machines crumbled, the chemical fingerprints of industrial activity could linger. Humor sneaks in again. Imagine an alien geologist 200 million years from now uncovering a mysterious alloy and thinking, "Ah yes, primitive humans clearly invented metal. Oh wait, not humans." Ultimately, the Silurian Hypothesis is less about proving that civilizations existed pre-dinosaurs and more about stretching our imagination and perspective. It reminds us how brief human history is in the grand scheme of Earth's timeline, how fragile civilizations can be, and how the planet constantly reshapes and erases its own memory. Humor, subtle but persistent, arises from imagining our ambitions rendered almost invisible by time, like a cosmic punchline played over hundreds of millions of years. So as you drift into a quiet state of thought, Imagine a world where cities rose, machines hummed, and intelligent creatures walked across Earth long before the dinosaurs. Perhaps they thrived, perhaps they fell to disasters beyond their control. All that remains, if anything, are tiny chemical traces and strange anomalies in the rock record, like whispers from a civilization the Earth itself has nearly forgotten. And maybe, just maybe, that's the most soothing thought of all, that life is resilient, curious, and endlessly inventive, even if it sometimes disappears, leaving the planet to start anew, quietly and without fanfare.